So today's topic is Kruskal's algorithm. What exactly is algorithm is for? Kruskal's algorithm basically finds a safe edge in order to grow the forest. And what is a forest? A forest is a collection of trees. So if we are having multiple nodes, so the Kruskal finds to join a safe edge in order to add different trees, and the trees which are having least weights on their transition, or you can say edges. So here is the algorithm, and there is one example which is solved in the book, and we will go through with the example as well. So let's see the algorithm. Here G is your graph, which is basically it's an argument for the function of minimum spanning a tree algorithm, that is Kruskal, which we are studying at the moment. And what is W? W is the set of weight uh, which is available on each transition, or you can say these are the magnitudes on each and every transition. So in the beginning we start with a variable a, which sets to 0, and for each vertex, so vertex are the nodes basically. For each vertex v, which belongs to the set of all the vertices in the graph, that is g dot v, we need to make set. So make set is a small function which is creating a set of vertices from the graph. So it is just grabbing the different vertices. So sort the vertices of the graph edges into non-decreasing order by weight. So non-decreasing means increasing order, so it's ascending in order. So we need to sort out all the edges. So E, capital E, stands for edge here. Yeah. So for each edge, so what is an edge? Edge is a transition which joins two nodes or two vertices. So for each edge which is joining U and V, which belongs to the set of graph edges taken in non-decreasing order by weight. So if this is the iteration, there is an condition that if we find set of U which is not equal to the find set of V, means the two trees are different, so both having different sets. If both having different sets, then A will be equal to A union U comma V. So here is basically the selection of safe edge which joins two different trees, and then we are simply making a union of U comma V and then return A. So for every value of A, we are just simply increasing the size of our forest. So how we can implement this algorithm? Let's have a quick look to the example. So let's see, we are having different edges over here, like A, B, C, D, E, F, G, H, I. So these are 9 edges at the moment with different weights between them. So A is connected with B with the weight of 4, and A is connected with H with a weight of 8. So we need to find out minimum spanning tree. That means a tree which spans all the vertices with least weight values. So just remember this thing, that spanning tree, span means to span, to cover the area. So the tree is basically covering all the vertices with least weight values, so that's why we call it a minimum spanning tree. So Kruskal's algorithm is based on the weights. So in every step, the very first thing, because it is in increasing order, non-decreasing means increasing order, so the very first value of the weight is 1, so it identifies H and G should be connected with the help of edge which contains weight 1. So we are connecting H with G. The second weight after 1 should be more than 1, so it's 2. So we are having two different options, whether we can take this 2 and the other one. So we are taking this 2 because it is outside the set of the previous tree. So I is connected with C with the help of 2, and when we join IC in the third figure, we are joining G with F with the help of 2. So we are basically increasing the magnitude or the weight of each transition and adds those transitions to the minimum spanning tree. So the very first transition was in between H and G with the help of 1 weight, then I to C with the help of weight 2, then G to F with the help of 2. So as we moves on, after 2 we are having a 4, which is A and B, and then there is another 4 which is in between C and F. Then we have 6. So we need to skip this 6 because 6 creates a cycle along I, C, F and G. So it makes a cycle, but the minimum spanning tree cannot be a cyclic graph. It should be a cyclic graph. So we must ignore this transition. So after 4 we must go through with 6, but 6 shall not be the part of our tree, so we need to skip 6 and jumped towards 7. So there is 7 between C and D, and there is another 7 which is H and I. So we first took C from 7 C to D having the magnitude of 7. The other 7, again, if we add this particular transition which is in between H and I, it also creates a cycle between H, I, C, F, G. So we should not take this particular transition because it creates a cyclic formation. So we reject that 7, and here you can see that after 7 there must be an 8. So there are two possibilities of 8. So we choose the first 8 which is in between A to H, and then there is another 8. If we choose this particular 8, again it creates a cyclic fashion between A, B, C, F, G, H and back to A. So we need to skip this particular 8. So after 8 there is 9, so we just join 9 between D to E, and after 9 there is 10, and we need to skip 10 because it also creates a cycle, so we need to skip this 10. After 10 there is 11, and we need to skip 11 as well because it creates a cycle between A, B and H. And after 11 there is the last transition between D and F, which is 14, and if we join this particular transition it also creates a loop between C, D and F. So after completing all the transitions and identify those transitions which are not creating the cyclic structure, we can conclude a minimum spanning tree with the help of Kruskal's technique. So in the last picture you can see that all those nodes A, B, C, D, E, F, G, H, I, J are connected with the help of at least one transition. So we can move from A to B or A to H, then H to G and G to F and F to C. From C we can move to I, or C we can move to D, and from D to E. So this completes the overall tree with the help of Kruskal's algorithm.